Hey everyone, and welcome back to the Cyber Defense Lab, a podcast that talks about everything to do with cybersecurity. And this is going to be a really exciting episode today because it's about robots. And the episode today is entitled When Cybersecurity Makes Robots Move. So welcome back. This is going to be an exciting one. So thank you very much for following me on my lovely cybersecurity journey. I'm up to nearly about 11 months into cybersecurity learning, and it's absolutely fantastic. So welcome back, and today I want to start with something sitting right in front of me. It's a robot. Well, technically it's a die-cast model of a robot. It's a KUKA KR QUANTEC. It's one of those instantly recognisable orange industrial robots that you've probably seen in factories, like automotive plants or, just manufacturing facilities, and increasingly in all sorts of automated environments. And looking at this little model got me thinking about something that, for cybersecurity professionals is actually a pretty important question. What happens when the thing we are protecting isn't just a computer? Have you ever thought of that? I haven't until now. And I'll explain a little bit more about, the unraveling of security engineering that I've been reading that has kind of prompted me really just to do this episode. So, because traditionally when we talk about cybersecurity, most people immediately think about phishing emails, malware, viruses, ransomware, somebody clicking a dodgy link. And I've had some malware attempts this week as well. Thank you very much, whoever's doing that out there. Not good people, but it keeps me on my toes. Maybe someone's stealing a password. And all of those things are absolutely cybersecurity problems. But there's also another cybersecurity that is becoming increasingly important. And that's when the computer just isn't displaying information. The computer is controlling something physical, whether it's a machine, a conveyor belt, a power system, a water treatment plant, even a production line, you guys. Or, in our case today, a robot. And I want to talk to you about KUKA. Now, I found this company actually looking through eBay, and there was a robot for sale, and purchased it. And I got it, and it's absolutely amazing. I did first of all write to the lady and say, hey, has it got like an app you can download? Can I stick a USB in it and just do some programming with Python and everything to make stuff move and everything? But she says no, it's just a die-cast model. But I got it, and I don't know whether you know, but KUKA is one of those companies that is deeply connected to the history of German engineering and like industrial automation. Because I didn't realise that until I got looking into it. So the company was founded in Augsburg in 1898, so quite some time ago, by Johann Joseph Keller and Jacob Knappich. And today KUKA is headquartered in Augsburg, which isn't actually that far from me, hence the interest. And today KUKA is headquartered in Augsburg and operates globally in automation, robotics, logistics and related techniques. Even in Australia they've got it, which is absolutely fantastic. And if you've ever seen one of those bright orange KUKA robots working in a factory, you've probably seen the result of more than a century of engineering evolution. So KUKA entered the industrial robotics in a major way in the 1970s with the Famulus, which is, I don't know if you know, but it's like a 6-axis electromechanical industrial robot. It's absolutely freaking amazing. But over the decades, these machines evolved from relatively specialised, like industrial equipment, into highly sophisticated robot systems that can interact with modern digital production environments. Which brings us to the robot sitting on my desk, the KR QUANTEC. KUKA describes the KR QUANTEC as the high payload industrial robot family designed for a wide range of applications, from automotive manufacturing and foundries to medical applications. And this is why, when I had a recent chat on an interview where this communications company is really deeply embedded into the hospital scene, I said, do you know you're on the front line of cybersecurity attacks? And this guy just kind of wafted his hand through the air like, yeah, that doesn't matter. It does matter. It really, really does matter. Because it's, machines like this that do medical applications that really, really does count at the end of the day. And there's lots of KUKA machines, and depending on the versions, these machines can have payloads ranging from about 120 to 300 kilograms, with reaches extending to nearly 4 meters. So these things are really big. They're really big. So we're not talking about a little robot vacuum cleaner here, or the die-cast model that's on my desk right now. We're talking about a machine capable of moving hundreds of kilograms of equipment, of material, with incredible precision. And here's where the cybersecurity gets interesting, because that robot, remember, doesn't operate in isolation. It's not like you can air gap it, There's software, there's a controller, there are networks, and there are engineering workstations. Remember, of course, there are interfaces and configuration files, credentials, which are really important, and there are also maintenance systems. But these can be connected to other machines and systems within a production environment. So if you're in cybersecurity, just kind of remember that nod to the industrial sectors, as they can be quite vulnerable too. So cybersecurity can become part of physical safety. But I just want you to think about the difference for a minute. Like, if somebody compromises your laptop, perhaps they steal documents. That's pretty bad. If somebody compromises an online account, perhaps they steal some money, and that's bad too. But if an attacker compromises an industrial control system, the consequences can potentially extend into the physical world, because the output of the computer isn't necessarily pixels on a screen. The output could be move this motor, open this valve, start this conveyor, stop this process, or change this parameter, or move this robotic arm. But the fundamental concept behind what we call operational technology, or OT, is, really, really important when it comes to IT, which is largely concerned with information. Because the operational technology is concerned with monitoring and controlling physical processes. And if you're in your cybersecurity journey and you're quite early into it, you're going to see the words OT coming up quite a lot. And it's not occupational therapist, everyone, okay, in this sense. So, we've got these modern factories increasingly sit between basically two worlds, because we can't air gap them, like I said. It'd be lovely to, wouldn't it? But the convergence is increasingly powerful. It gives manufacturers data, automation, remote monitoring, predictive maintenance, digital twins, nicht vergessen, in German, as I speak German all the time, and analytics, artificial intelligence, greater efficiency. But every connection can also include another security consideration. And I just want to kind of hop on to, and I'm just leaving the desk for a minute to find the book. 1 second. All right, so I'm back again. So what I'm currently doing, I'm at the University of Kempton, and using their library for my cybersecurity purposes, and it's been wonderful. I've been there for a couple of weeks now, and even the lady that I think she's in charge of the library. She's asked me if I can actually advise them on the cybersecurity books that they've got coming in, and keeping them up to date to make sure that everything's relevant. So I picked up the Security Patterns book, Integrating Security and Systems Engineering, from Marcus Schumacher and all the other guys, which is amazing. And if you're wondering about, what this book is about, I mean, it's absolutely fantastic. I mean, it's so my bag. It really just takes me to the next level, which Donella Matthews did with Thinking in Systems book, which is, her, one of my favourite books of all time. But unfortunately, she died, I think, in like 2009 or something, and her editorial team published it as well. So if you are into security patterns, check out Donella Matthews' book as well. But I was just looking at some RFID stuff as well, which is the radio frequency identification. So that's where I'm up to at the moment. And it got me really thinking, with this die-cast model in my hand and stuff. It's like, okay, can we actually, kind of infiltrate these operating systems of the KUKA machines and everything with kind of some radio frequencies as well. So it indicates that I am not just putting like a toe into the water of the robotics area. I've actually basically put both feet in there really. But let's go back to KUKA for a minute. And there's also another interesting connection as well. So if you look at KUKA, you notice something really obvious, that the robots are orange, right? And KUKA itself actually talks about orange intelligence. So orange intelligence in German, because it's in Germany. So intelligence, you don't put the GENCE at the end of the word, you put GENZ like they spell it in German. So orange intelligence as part of its brand identity. And KUKA describes that concept as the combination of intelligent people and intelligent machines, bringing together software, hardware, mechanics and systems at the interface between the virtual and the physical worlds. And it's that phase, really, everyone, that the interface between the virtual and the physical worlds is exactly where today's cybersecurity story lives. And because that boundary is something that we're increasingly trying to defend. But it's also, it's weird living in Germany sometimes, because another name that people in Germany do recognise is called Orange Cyber Defence. Now, to be precise, KUKA's orange branding and orange cybersecurity defence are not the same thing, okay? And I don't want to suggest that they are one company, but there's a fascinating thematic connection here. Because Orange Cyber Defence works in cybersecurity, including industrial and OT security, where the challenge is to protect connected physical environments. You've got the Orange Cyber Defence has specifically discussed the security of connected industrial objects, including robots, and its industrial security material focuses on the convergence of IT and OT as well, of course. I think there's a nod to Hello Future on that one, really, but that gives us a really useful way to explain the problem. And I just want you to just sit there and just close your eyes a minute and just imagine a factory. You've got a network there, you've got computers, you've got engineers, you've got a production management system, and then you've got a robotic cell. The robot might be perfectly safe when everything around is trustworthy, but cybersecurity asks a different question. What happens if something that the robot trusts is no longer trustworthy? You can open your eyes now. Because that's a really different question from did someone send us a phishing email? Because now we're talking about trust relationships, we're talking about authentication, we're talking about authorization, who can use it, network segmentation, secure communications, that's really, really important, patch management, vulnerability management, monitoring, instant response, and critically, safety, right? KUKA itself has a dedicated cybersecurity program, and the company says it investigates vulnerabilities and threats, provides security updates, operates a vulnerability reporting process, and works with CERT-AT VDE, and industrial cybersecurity. On industrial cybersecurity, I didn't know whether you knew that or not. But also KUKA also says that its product development process has been certified according to IEC 62443-4-1, which, if you didn't know, is like a major industrial cybersecurity standard. I mean, just look at KUKA Australia, for example, on that one. But that's a really important point, is that cybersecurity isn't something you bolt onto a robot after you've been finished building it. You know, increasingly security has to be considered throughout the lifestyle. So you've got the design, you've got the development, deployment, configuration, operation, and maintenance, of course. And eventually, decommissioning. Please don't forget, like decommissioning, okay? Because industrial robots can have very long operational lifetimes. A laptop might be replaced after a few years, a production system can be expected to operate for much longer, and that creates a fascinating cybersecurity challenge. A machine that was designed years ago might now be connected to a network that didn't even exist when the machine was first installed, and that's the world of industrial cybersecurity. And I mean, just look at Boeing. Just look at the 737 that they're still running. What are they still running? They're still running 3.5 inch discs for their load up session before the plane like systems checking and everything else. So you can, yes, and people, they're still doing that. They're still using floppy disks that we used to use in the 90s. Okay, anyway, I digress. But here's the thing I really want you to take away from this episode, that cybersecurity isn't necessarily about stopping someone from stealing your data. Sometimes cybersecurity is about making sure that the right thing happens in the physical world. It's about ensuring that the right person can issue a command, that the command comes from a trusted system, that communication hasn't been manipulated, that software hasn't been tampered with, that vulnerabilities are managed, and that unusual behaviour is detected. And that, if something does go wrong, the system can be brought into a safe state. Because ultimately, an industrial robot doesn't know what a cyber attack is. It doesn't sit there and think, this command looks suspicious, does it? I mean, it executes the instructions its control system is designed to execute. So that's why the cybersecurity architecture surrounding that machine matters so much. And this is where IT security professionals and OT engineers increasingly have to understand each other. There's an IT security team might be looking at authentication logs, network traffic and endpoint alerts. But the OT engineer might be thinking about cycle times, machine states, safety systems and production processes. Both are looking at the same environment, but they're just looking at it from a different perspective. I hope you've got the grip here. And the modern industrial environment needs both. So coming back to my little QR QUANTEC model, it's obviously not connected to anything. At least this one isn't. It can move. It's really good. It's got the plungers and stuff, and it's lovely. But it can't hurt anyone unless I fall over it. But it's orange, so I'll probably see it first. You know, it's just a miniature representation of a machine. But the real machine represents something much bigger. It represents the point where software becomes physical action. And that is one of the most important ideas in modern cybersecurity. A further technology moves into the physical world, the less useful it becomes to think of cybersecurity as simply protecting computers. We're protecting systems, we're protecting machines, don't forget, and we're protecting processes, but also we're protecting people. And sometimes we're protecting the physical world itself. So the next time you see one of those bright orange KUKA robots operating behind the safety glass of a factory cell, just don't think that's a robot making Elon Musk's cars. I don't know whether they do. They might do. But it's about everything behind it. It's the controller, it's the software, It's the network. It's like even the engineering workstation, you guys. The credentials, the updates, the protocols, the monitoring, the safety systems. There's a lot that goes into it, really. And all of the trust relationships that allow the machine to do its job. Because that is cybersecurity too. And perhaps that is one of the most simplest ways of explaining the difference between traditional IT security and the emerging world of industrial cyber defense. The computer just doesn't contain information anymore. Sometimes the computer controls the world around it. And when that happens, cyber defense becomes physical defense. So thank you for listening, really. You've been listening to the Cyber Defense Lab podcast, and I love doing this. It's absolutely brilliant. I'm your host, Simon Arnold, and it's been a slightly different look at cybersecurity, starting with a little orange robot on the desk and ending with very machines transforming modern industry. So until next time, stay curious, stay secure, and remember, if it's connected, it needs defending. Catch you next time.